Hi people, today we're going to work on 5.4 mutually exclusive events. So just kind of a reminder, mutually exclusive events are disjoint sets, as in they have two circles that are separate from each other, as in there's no overlap, and the two things can't happen at the same time. So they are separate from each other, there's not that overlap piece. And when we try to find the probability of something like this, it's really easy because there's no overlap to worry about. We just add the probability of this plus this and we're done. Easy. It's a little bit more annoying when they are not mutually exclusive because we have to worry about how much is overlapped between them because you don't want to like double count those things. So if they are not mutually exclusive, we can take the two probabilities and subtract the middle so that we're not double counting it. Or you can think of what's the probability of just C happening, what's the probability of just D happening, and then what's the probability of the middle. So that's just what that second formula says. It depends on what you're looking for, and typically you're not going to think, oh, what's the formula for that, and then use it. No, you're just gonna calculate using what you know. All right, so let's try some of these. We're going to decide if something is mutually exclusive or not, and then we'll find the probability that each player will win. Monica rolls two four-sided dice. She wins if the product, which is multiplying, that's something we need to know, is even or greater than 6. So we have two four-sided dice, and we're going to roll them. Now, this is a really helpful place to have a table. So let's make ourselves a table where we're going to fill it in with the whole sample space of what could happen. So along the top, I'm going to go, what can happen to the first die? Well, we could roll a 1, a 2, a 3, or a 4. The second die I'm going to put along the side, we could again roll a 1, a 2, a 3, or a 4. And on the inside of this table, that's where I'm going to put the products. And that will be our sample space, or our universal set of everything that could happen. So I'm looking for products. So product is multiply, let's multiply. 1 times 1 is 2. No, that's not right. 1 times 1 is 1. I don't know why I said 2. Here we go. And then we'll do some more multiplying. Hopefully I don't make a mistake again here. Alright, beautiful. So I'm looking at this area in here. Those are all the different products that I could get. Now, Monica apparently wins when she gets an even number or a number greater than 6. So I'm going to circle all the even numbers with my little red pen here. And let's see how many there are. Oh, quite a bit actually. Alright, that's all my even numbers. And then maybe greater than 6, I'll do something with a pencil here. Maybe I'll put a box around them in pencil. Greater than 6. So does 6 get included in that? I would say no, because 6 is not greater than 6. It's just regular 6. So 8, 9, 12, all those ones. Alright. Now you'll notice that I put a box and a circle around some of these numbers, right? So if I were to make a Venn diagram of this and I have my two circles, would they be overlapped? Yeah, I think they would be overlapped because there are some things that would be in the middle, right? So if the things are in the middle, that means they're overlapped. That means they are not mutually exclusive because these two things can happen at the same time. So not mutually exclusive. These circles would not be disjoint. All right, now let's find the probability. So probability equals how many things are favorable? How many would give us a winning roll? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 things that I counted here, and I didn't double count things that were double circled. Like 16, I only counted that once because it's only one outcome that could happen. 13 out of, and there are 16 total outcomes. So our probability is 13 out of 16. Let's try this one. You know what? You do this one. Let's do this one. Katrina rolls 2 4-sided die, 1 red and 1 blue. Great. She wins if the quotient is dividing, PS, is either a whole number or a terminating decimal less than 1. All right. I'm just going to set myself up, and then we'll talk about what terminating decimal means. 1, 2, 3, 4. I do need a little bit more space on this one because my writing is pretty terrible, as we all know. All right, this time, quotient means we're going to be dividing. So it doesn't really matter which side we divide by which side, as long as we're consistent. So I'm going to take these numbers and divide by those numbers. And then looking for whole numbers, which is easy, or decimals that end, that are less than 1. So, for example, 0.33333, that is not terminating because it doesn't end. It would keep going on and on and on. If I had a really big calculator, it would show me like a lot of 3s. So let's divide and then we'll talk about it. 1 divided by 1 is 1. 2 divided by 1 is 2. I really had to think about that one. Okay, those are easy. 1 divided by 2 is 0.5. 2 divided by 2 is 1. 3 divided by 2 is 1.5. 4 divided by 2 is 2. 1 divided by 3, 0.3 repeating. And I actually hate this repeating, that symbol. It just drives me nuts. When in general in this course, we do not use this symbol. I'm only using it on here because, number one, I have very little space, and number two, because it shows that it's not terminating. But for us, in general, we round to 2 decimal places. Okay, I don't know why people love using this little symbol, but it drives me bonkers. 0.6 repeating, 1.3 repeating. I hate that symbol. I don't know why it drives me so crazy, but it does. Alright, so we're looking for whole numbers, which is easy. I'm going to put that one in red. Whole numbers are 1, 2, 3, 4. Oh, and there's a 2 in there too. Okay. Basically nothing with a decimal. And then terminating decimals less than 1. So we're looking for things that are less than 1 and things that do not have that little symbol, that it's just 0.5 and that's it, right? There's no other values after that. So 0.5 is 1. None of these repeating guys are them, but these all are. How about 1.5? No, because it's not less than 1, right? It is a terminating decimal, but it's not less than 1. Now let's look at this. Is anything doubly circled, like box and circle around it? I don't think so, right? So I would say that this is mutually exclusive. And our probability, we don't have to worry about double counting anything. We're just going to count everything that's kind of marked up on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 out of 16. You certainly could reduce it, but you don't gotta. So leave it. Alrighty. Very similar question. Very similar question. Let's try some more here. Now, when, like in this question down here, this is an inside joke to community, by the way, a 4-sided die and an 8-sided die. It doesn't get harder. It just gets more annoying to write down all the things in the sample space, right? It's not harder, it's just more. Very similar question. Let's look at something a tiny bit different here, where we're going to look at our Venn diagrams again, because I know it's been a while since we talked about Venn diagrams, but Venn diagrams are super helpful to help us figure some stuff out. The school cafeteria results from earlier in the year found that 58% of students skip breakfast, that's not good, 29% skip lunch, and 22% eat both breakfast and lunch. Determine if skipping breakfast and skipping lunch are mutually exclusive. What I want to know is, are these two circles separate or are they overlapped? And a great way to see that is to make myself a Venn diagram and see which one happens. So, Venn diagram, very first step, I need a box. Even if I'm just doing like rough work, like it doesn't ask me for a Venn diagram, but even if I'm just doing that to help me figure it out, I still need that box. Let's call it U. I'm not going to draw my circles yet because I don't really know. But my circles are going to be skipping breakfast and skipping lunch. So what's going to go on the outside? Who skips neither? Like they're eating all their meals for the day. Well, these guys, right? So these guys are going to go on the outside, 22%. And remember with Venn diagrams, if they have percents, you throw some percents on your values. All right, so if 22% is outside the circles, then what percentage is going to be inside the circles? Well, let's take 100%, because that's what the box should add up to. Subtract the 22, and I get 78%. That will be the inside circles. So inside those circles should be 78%. But let's look at the other percents they gave us. They gave us 58 and 29. And not so good with the mental math here, but I'm pretty sure that's going to be over 78. So let's just add that and see what that adds up to. 58 plus 29, 87%. So what I've done here is I've found 87% of responses should be in these circles, but I really only have 78% of kids. That means that there's some overlap, which means I can totally draw my circles as overlapping circles. I'm going to call this skip breakfast, skip lunch. How much is the overlap? Well, how much bigger is 87 than 78? 9%. That will be our overlap. So 9% is going to go in the middle. Now remember, to figure out the other sides, we have to subtract. So 58 minus 9 is 49%. 29 minus 9 is 20%. And let's just do a real quick check that these all add up to 100. Let's pretend I do that because I'm a little too lazy, to be honest with you. But yeah, here we go. Adds up to 100%. Are these two things mutually exclusive? No. They have an overlap. No. Not. I'm not even going to write it down because I ran out of space. Not mutually exclusive. There is an overlap. So not mutually exclusive. Determine the probability that randomly selected students skipped breakfast but not lunch. So, remember we had a very specific notation for when we say they want to do something but not something else, like this and not that. Like we want to be able to say just this. We don't want to include those 9% that have also skipped lunch. We just want to know how many people just skipped breakfast. So our notation, if you remember, looked like this. Skip breakfast, backslash, that means does not skip lunch. Just practice notation is always a good idea. And I can see it right from here. I can see 49% because I don't want to include the 9 that did both. So 49%. I really did all the work already for that. Determine the probability that a randomly selected student skips at least one of breakfast or lunch. So at least one of, and that or, that gives us a hint that we're talking for the union. So if I'm looking at my Venn diagram here, I'm talking about the people who skip breakfast, the people who skip lunch, or the people who skip both. So I'm actually talking about the entire circle-y area here. And I've already figured out that that should be 78%. So let's use some notation. Skip breakfast or skip lunch, 78%. Beaut. Let's flip, see what's on the next. Alrighty. So this question is very, very similar to that last one. You can certainly give this one a try on your own, this Civil War question. Let's do this one. It's a little bit different. It's kind of making decisions. This is a specific outcome from your curriculum, so that's why we're going to talk about it. But I gotta say, typically you're not given all this information when you're trying to make a decision. So Colton's parents bought a new TV, 60-inch TV, and a new theater sound system on Boxing Day. How exciting for you. Best Buy offered them a 3-year extended warranty for $200. He was skeptical, so he researched the repair statistics. Probably harder to do than this would lead you to believe, but that's no problem. The TV they purchased required repairs 6% of the time, and the average repair is $150. So Not very common that they need repairs, but a pretty big cost if it does need repairs. The sound purchased, okay, slightly bigger, but still very small chance, and a little bit cheaper. The percentages of customers who had to get both repaired was 2%. Do you think that this is a good idea or not? Now, this is a super up to you choice, because some people love to buy warranties and some people don't. Personally, my husband will buy any warranty ever. I'm just going to call this a thing, just so I can say TV, sound system, both. What are the chances of repairs? We're going to make ourselves a beautiful table here. Now, you can certainly make, informed decisions, but typically you don't know what are the chances that this thing's going to need repairs or not, right? Cost or savings? I'll show you how we're going to fill this in here. Oh, and apparently I didn't need this last space. I just kind of accidentally made too many. Okay, so the thing, let's start off with the TV. What are the chances of repairs? 6%. How much does it cost? Well, let's think about this. So if we were to get the warranty for $200, but the TV only costs $150 to repair, really you're out money because you spent more than you needed to on that repair. Because if only the TV breaks, it's only $150, so you'd be out. So I'm going to call this negative $50 because you really shouldn't have bought the warranty. You should have just gotten it fixed when you need it fixed, because only one thing needs to be fixed. Oh, sorry, I meant to put that over here. Oh my gosh, what's going on here? Struggle. So the repair cost is $150, and really it's a. Oh my gosh, I'm really struggling. It's a cost. Like it's not a good idea. If only the TV needs to be repaired, hindsight you'd have been like, oh shoot, I shouldn't have bought the warranty because it's not worth it for me here. I actually end up spending more money. Let's pretend I get the sound system. The chances of repairs are 7%, so a little bit higher, but still really quite small. The repair cost is $130. And if only this breaks, but I bought the warranty, well, I'm kind of out $70. If it doesn't break at all, then I'm really out money. But if it does break and I bought that warranty for both the items, but only one broke, I'd be out $70. So if either one of these breaks, just one of them, it's really not worth it. But let's do both, because this warranty covers both of them. There's a 2% chance they both break. If I had to get them repaired out of pocket together, that'd be $280. And this is the one time that it would probably make sense to buy the warranty, because I bought the warranty for $200. Getting it repaired on my own would cost $280, so I saved myself $80 if both break. Now here's where you have to think to yourself, does this make sense for me to buy the warranty? Well, there's only one outcome here where you save money, which is if both break. Because if nothing breaks, obviously you're out $200. If only the TV breaks, you're out $50. If only the sound system breaks, you're out $70. The only time that you're good to go here, that you've made the right decision, is if both break, and there's only 2% chance of that. So I mean, probably not the best choice to make, you know. So my dog's doing something weird, just making a weird noise. Okay, so I would say probably not buy it. Do not buy. Do not buy. Only a 2% chance of saving money. What I always try to think about with warranties is the person who's selling the warranty is doing it for a reason. They're selling that warranty at that price because they're making money off of us. So if it's like a TV that doesn't really cost that much money, I probably won't buy the warranty. If it's a couch that I know I'm going to be using every single day for, however many years, and I have 3 dogs and they're all going to be on the couch and yada yada, I probably do buy the warranty because I know I'm going to be really hard on the couch. But otherwise, I typically don't. My husband will buy literally warranty on anything. Like the laptop I'm using right now, he bought the warranty for that. Not really sure why, because I'm not good at keeping laptops good. Anyway, different problem. That's that type of question. This is kind of like those other ones we were just doing, so give this a shot if you haven't already. See how it goes. Here are some of the textbook questions to practice. See how they go, and have a good night.